Okay, we had then seen what is the frictional factor, how it is defined, and how we can find out from Moody's chart, right. Now, let us look subsequent things that after the Moody's friction factor, once that is done, we can see that okay, next we handle it with a problem for given one. This is of course nothing but a mathematical problem. For a turbulent flow in a pipe, it has been established that V is equal to V max into 1 minus R by R to the power 1 by 7. So, then you have to calculate the average velocity. So, the problem is for turbulent flow in a pipe, it has been seen that V is equals to V max, right, times 1 minus small r to capital R to the power 1 by 7. So, if this is there, then what is the value of V average, right. Now, we have shown earlier for pipe flow also we have shown that when you are doing it for average flow, that average flow is defined by this way, that V average is equals to 1 by pi r square 0 to r, right, V 2 pi r dr, right. And this can be written as 2 pi divided by pi r square, right, into V r dr, right. This is between 0 to r, right. Now, this can be written as 2 V max over r square, right, and 0 to r and 1 minus r over r, 1 minus r over r to the power 1 by 7 r dr, right. So, this we can also write is equals to 2 V max, right, over r square between 0 to r, right. Now, let us define this as x is equals to 1 minus r over r. Let x is equals to 1 minus r over r, right. Therefore, we can write small r is equals to capital R into 1 minus x, right, or we can also say dr is equals to minus r dx, right. So, if that is true, we can say for 0 or r is equals to 0, x becomes equals to 0, and for r is equals to r, x becomes equals to 1. So, this which we had earlier done, okay. Now, this we can replace for r is equals to 0 to r is equals to r. So, r is equals to r, it is 1, and r is equals to 0, it is 0, right. So, this is x to the power 1 by 7 r 1 minus x into minus r dx, because dr is minus r dx, right. So, between 0 to r is equals to 0, x is equals to 0, r is equals to 0, x becomes equals to 0. No, for r is equals to 0, you see r is equals to r, so this goes out, x becomes equals to 1, right, and for r is equals to 0, x also becomes equals to 1. Okay. For r is equals to 0, x becomes equals to 0. For r is equals to r, x becomes equals to 1. So, it is 0 to 1, x to the 1 by 7, r 1 minus x into minus r dx. Okay. So, if this is true, then we can write this is equals to minus 2 V max, right, over r square, right, and here also r square, this r and this r makes r square, right, and this we can write between 1 to 0, x to the power 1 by 7, 1 minus x dx, right, 1 to 7, this minus we have taken out, right, this minus we have taken out, minus 2 V max, this r has made r square, already there is one r, okay, and this was 0 to 1, right, x to the power 1 by 7, right, 1 minus x dx, right, and only one thing, which is x is equals to 1 minus r by r. So, when x is equals r is equals to 0, so x becomes equals to 1, when r is equals to r, x becomes equals to 0. Oh, that is what was the problem. R is equals to 0, x is equals to 1, and when r is equals to r, x becomes equals to 0. That is what it is. When r is equals to 0, x becomes equals to 1, r is equals to 0, x becomes equals to 1, and when r is equals to r, x becomes equals to 0. When r is equals to capital R, then this is 1, x becomes 0. So, it should have been 0 to r. So, from there it is x is equals r is equals to 0, that means x becomes 1, and for this 0. So, this was our original, right, 1 to 0. So, that means this we can write to be equal to minus 2 V max r square by r square 1 to 0 x to the power 1 by 7 1 minus x dx, right. On simplification, we can write 2 V max, right, r square goes out, and now with a negative, then we can write it to be 1 to 0 x to the power 1 by 7 dx, right, minus 1 to 0 x to the power 8 by 7 dx. This is 1 by 7, right, minus 1. So, it is 8 by x to the power 1 by 7 into 1, that is 7 plus 1, 8 by 7. So, x to the power 8 by 7 dx, okay, 1 to 0. Now, this we can rewrite to be minus 2 V max, right, and between x to the power 1 by 7 means x to the power 8 by 7 divided by 8 by 7. This is between 1 to 0 minus this one x to the power 8 by 7, right, 8 by 7 plus 1, so 15, x to the power 15 by 7 over 15 by 7, right. So, this is also between 1 to 0, right. So, if this is true, then we can write that this is equals to minus 2 V max, right, times, now this we can write x to the power 8 by 7 and 0 and 1. When we put this limit, then we can write 1 by 8 by 7 plus 1 by 15 by 2, right, because this, when we had seen, this was between the 2 minus 2 V max, we maintained minus 2 V max, right, and this was x to the power 8 by 7 by 8 by 7. When x is 1, right, then automatically 1 minus comes in. When x is 1, automatically, because this is 0 minus 1, so when x is 0, this is 0, then 1 minus 1 minus this, that 1 by 8 to the power 8 by 7, and this is minus 1 by 15 by 7. So, that is what we got, and this 1 minus and that minus made us this is plus, right. So, this on simplification we can write V max, right, V max times 1 minus 1 by 8 by 7, which we have written. So, it is 7 by 8 minus plus 2 by 15, right. So, this is nothing but 2 V max. So, our denominator 2 V max, of course, here we had a negative which we forgot, minus 2 negative. We have now 15 8 120, and this becomes 15, this becomes 8 2s are 15, 8 2s are 16 and 56, right. This is 8 2s are 16 minus 15 7s are 105, 15 7s are 105, right. It is okay. If we take 7, so 7 by 15 2 max and 7 by 8, no, this 15 by 7, how come it is 2? How come it is 2? This is x to the 1 by 15 by 7 and 8 by 7, okay. So, this is 1 by 8 by 7, this is 15 by 7, that is what the mistake was. So, it is 15 by 7. So, 2 V max 16, not 16, we can rewrite minus 2 V max, right, into this 7. If we take common, then it becomes 1 by 8 minus plus 1 by 15, right, or is equals to 7 2s are 14 V max, right, 7 2s are 14 V max, and this becomes 1 by 15 minus 1 by 8, right. So, this is 14 V max, right, 14 V max 120. So, this becomes 8 and this becomes minus with this negative was there, this negative is still there. So, if the negative is still there, then why do we carry out? So, this we can take that negative inside 14 V max, right, 1 by 8, 1 by 15, right, that is 1 by 15 over 1 by 8, right, 1 by 50, 1 by 8 minus 1 by 15. This is 14 V max, right, and 120 now. So, this is 15 minus 8, right. So, this is 14 V max, 15 minus 8 is 7 by 120, right, and if we divide, this becomes 2 or 7 and this becomes 60, right. So, it becomes 49 by 60 V max, right. This is nothing but 0.2817 V max, right. So, we could find out what is the average velocity. So, average velocity is 0.817 V max. This is a typical your problem. This kind of relations you can also generate and then find out what is the average value with the actual value, with the maximum value, right. But you must also know that the relation which you have put here, if you remember, we started with V max, V average, having a V is equals to V max so much, that relation which we gave. And so, you must have one such relation where it will have a meaningful relation and some value, like here we have found out this is to be equals to 0.817, right. Whereas, we started with that relation was V is equals to V max into 1 minus R over R to the power 1 by 7, right. So, any such relation if you have, then you can get the average velocity in terms of maximum velocity. So, we got the average velocity, this is equals to maximum velocity of so much, 0.817 times of maximum velocity. Keep in mind that this relation is just for one exercise to find out the average velocity, right, because average velocity, we if you go back to your previous that 1 by area times the area total. So, where that area integrated between the limit 0 to 1 or 0 to 2 pi, then R to capital R, like that, depending on your regime which you are handling with, and then find out and then get into it, right. So, this way we can determine a relation. Okay. Then let us also solve another problem quickly, so that we are accustomed with this, that a starch solution at 30 degree centigrade is flowing through a horizontal tube 0.3 meter long and 0.00254 meter inside diameter. For a pressure drop of 2.75 10 to the 5 Pascal, the flow rate is 1.127 10 to the minus 4 meter cube per minute. The density of starch solution at 30 degree centigrade is 1260 kg per meter cube. From the flow data, find the viscosity of starch solution. Right? I repeat, a starch solution at 30 degree centigrade is flowing through a horizontal tube 0.3 meter long and 0.00254 meter inside diameter. For a pressure drop of 2.75 into 10 to the 5 Pascal, the flow rate is 1.127 10 to the minus 4 meter cube per minute. The density of starch solution at 30 degree centigrade is 1260 kg per meter cube. From the flow data and the viscosity of starch solution from the flow data, find the viscosity of starch solution in Pascal second. Right? One thing we have given as hint that measurement of flow in circular tubes is one of the common methods of determining viscosity, and such devices are referred to as capillary viscometer. So, this is nothing but a problem of capillary viscometer. Right? So, if we find the viscosity, we will tell that this is the viscosity as measured by the capillary viscometer. So, capillary viscometer, if it is with your institutes, you can find out and check, knowing the other values, and check whether your predicted value and the actual value are matching or how far they are close, that you can determine. Right? So, let us look into the solution from the Hagen-Poiseuille's law. We know that mu is equals to pi into delta p to r square divided by 80 or 8 q l. Right? Mu is equals to pi delta p r to the power 4, not r square, r to the power 4 by 8 q l. Right? So, delta p is rather given pi into delta p is given 2.75 10 to the power 5 Pascal. Right? And r is also given as 0.00127, right, to the power 4, and this divided by 8. Q is also given as 1.127 10 to the power minus 4 meter cube per minute, right, times 1 minute by 60 second into 0.3 meter, that is L. Right? So, this becomes equals to 0.5 Pascal second. Right? So, viscosity we found out. So, we can say Hagen-Poiseuille Poiseuille. So, Hagen-Poiseuille law we found out the viscosity, what it is, what the value is, right. Now, we find out Reynolds number NRE is equals to d Vz average into rho by mu, that is equals to 4 q rho by pi d mu, right. So, if we substitute this values, then this we can write, this is equals to 4 times 1.127 10 to the power minus 4, so much meter cube per minute, 1 minute per 60 second, 1260 kg per meter cube divided by pi 0.00254 meter times 0.5 second or 0.5 Pascal second given, right. So, this becomes equals to 2.37, which is nothing but the flow is laminar, right. So, this becomes that the flow is laminar. Now, there is a term that is also called entrance length. So, in this entrance length LE is related with NRE as 0.36 D, 0.036 D NRE, right. So, this problem we have handled, and okay, we found out this to be 2.37, right. Now, I give you another problem which I don't tell you that this is assignment, but okay, some other day if you are not able to answer, we will solve it, and you first try. That is the best thing, you first try. If you are not able to find out the solution, I will definitely tell this, do not take it as assignment, but okay, giving a problem which you can try with, right. So, for example, a liquid of constant density is flowing in laminar flow at steady state in the horizontal x direction between two flat and parallel plates. The distance between the two plates in the vertical z direction is to z. Using a shell momentum balance, derive the equation for the profile within this fluid. So, I repeat, right, and hope you can do this. That is my expectation, that you can do this. Till now whatever we have done, from that basis you can do this. If again you are not able to do, obviously I will give you the solution, but first you try, okay, at least till now whatever has been covered, by that it can be easily done. So, a fluid of constant density is flowing in laminar flow at steady state in the horizontal x direction between two flat and parallel plates. The distance between the two plates in the vertical z direction is to 0. Using shell momentum balance, derive the equation for the profile within this fluid, right. So, I hope you can do this, because we have already done similar thing, and that similar thing, the pipe flow we have done. So, we can do it subsequently, right. So, in this problem, with this given problem, let us complete this class today, and next time if you are not able to solve, we will come across and solve it. Okay? Thank you.